And show me which one you want to do the most. Pick one.
I know.
We did two.
Pick one.
Three.
Two is easier to explain. If you explain it,
It's not even hard.
yes, I had three. I just don't remember how to do it.
Three more than two, so I'm gonna.
I say we do
I
both.
just need to count. If you're at 3, raise your hand.
Gary is that. I said stop. So raise your hand.
19, that's the majority of the class.
Let's do both, please.
You let us do both on other days. We don't even do it.
Sundays. I don't even know if this is right now.
I didn't finish it, but I put. It's not. What I think fun to back to.
And I didn't have
I should have all eyes and ears up here. Right, so this is asking us to find the solution of this system. Remember that there are 3 different ways to solve systems of equations. Which way do we want to solve?
Yeah, the easiest.
third way.
I heard elimination.
She said there's 3 ways.
Okay, so if we are solving these by elimination, which variable do we want to eliminate?
X.
Okay, can we do that now?
Like yes, indeed.
We need to multiply. We need these to be the same coefficient. So what would we multiply this equation by?
3. Or 2. It's not one by 2.
If you were doing block, yes. So, or by -3. So if I multiply this entire thing, I get 3x minus 6y equals 15. If we are eliminating our x's, what operation would we do to get rid of them? Subtraction. So we are subtracting this equation from this equation. So this becomes 0. Y minus -6y. Positive 7. 6 minus 15. Negative 9. Don't really need that 0. So when we divide, we get -9/7 or some weird fraction or decimal. And then we need to put this back in and solve for x. So I'm going to put that in here. In this example, how would we solve for x? Add what? Add 9/7. In your calculator, do that. 6 plus 9/7. What is that?
I keep forgetting how to put a fraction.
Alpha y equals 51/7.
That's what it says. I put them in as decimals.
You
Is
can.
that acceptable? Was decimals acceptable?
That's fine.
Decimal would be 7.28.
And then how would we get rid of, or how would we get x by itself? We could divide it by 3, but because we already have a fraction, I could also multiply by 1/3. It'd be the same thing. So I'd have 51/21. Does that simplify?
Yes, by 3.
So what?
7. No, wait.
Yeah, 17/7.
Yeah, 7.
So our ordered pair would be 17 sevens and negative 9 sevens. So yes, this one had really weird decimals or fractions for answers. If you put decimals, that's fine, as long as you put them for both.
Did we have to put like the full decimal thing? Point and then.
Alright, questions on this? Make sure you have this answer written down and pass up your answer sheet. So, last class, we were talking about solving inequalities, and we practiced that. And now we're moving on to the next piece, which is graphing them. And that's not just how we graph them on the number line. So we're going to go into more detail how we do that. But first, let's go back to how we were doing it. How would you read this?
X is greater than 3.
X is greater than 3. And if you get confused as to which way the sign goes or which sign goes which way, they are on the vocab board in the back.
How many days are there?
31. Okay. If we were looking for the solutions to this, what numbers would be solutions to this problem? Anything above 3. So 4, 5, 6, and we could keep going. Would this be an open or a closed circle?
Open.
Open, because it doesn't have the equal to underneath. And would this go to the right or to the left?
Right.
To the right. Now for this one, we could translate it as is. So as is, how would we translate this?
And negative 8 is greater than or equal to X.
Negative 8 is greater than or equal to X. Now, to find our solutions, it's best if we switch them. So X is less than or equal to negative 8. Now, I'm going to write that translation, but you don't need to. But it is the same thing. X is less than or equal to negative 8. So what would be solutions to this? You guys can say it out loud.
Negative 8, 6.
Now you guys are going
No, negative 8, negative 9,
this
negative 10.
direction. So it would be the other direction. Negative 9, negative 10. Would this be an open or a closed circle?
Closed.
Closed. And this would go to the left.
Where's that? 8.
Yeah, at negative 8. So we're taking that, but now we're going to graph them as we would graph a line. So take a second and read these 5 steps to yourself. Oh, I didn't
Yeah.
So it depends on if the variable comes first or not. So we should be reading to ourselves.
Use this to find the second one. Just 1 point or just?
To find. We're going to keep finding points.
Just keep going.
So when we graph these inequalities, it'll be very similar to how we graph lines. The only difference is the inequality changes some of the aspects of the line. So if we have something that is strictly greater than or strictly less than, that's going to determine what type of line we have. So if we have that, we're going to have a dashed or a dotted line. You'll see what I mean when we do some examples. If we have something with an equal to, so greater than or equal to, less than or equal to, then we'll have a solid line. So that'll be like the lines we draw all the time. if we have something that is larger, so that means greater than or equal to, we're going to shade above the line. So you'll see what that looks like here in a second. And then if we have less than or equal to, then we're going to shade lower than the line, or below the line. Okay, so let's see what that looks like. Before we even do the graph, let's fill in these three things. The inequality says that y is, what type of symbol is this? Greater than or equal to. So we will shade the graph above or below? Above, because it's greater than. And we will use a dashed or a solid line. Solid because it's equal to. So eventually these words will go away. You are next. These words will go away, but these will be the questions you're asking yourself. What direction is the inequality? What does that mean for your line? What type of line will you have? What direction will you be shading? So now let's graph this like we normally would. Where would we start?
Y-intercept 6.
Y-intercept at 6. And then our slope is negative 2/5. What directions will we go to get there?
Up and left, down right.
Up and left or down and right. So down to right 5 as many times as possible. And up to left 5 as many times as possible. So in this case, we know that we have a solid line, so that's just going to be me connecting the dots like normal. And then it says we need to shade above this line. So we need to shade above it. You could draw arrows if that helps.
Shade it.
And shade it however you like, whether that's drawing lines, shading the entire thing. I'm just going to do this to show that's where I shaded it. So if you don't shade it, you really don't have an inequality, whether you make the line dashed or not. Because the shading is really showing you where all of your solutions are. All of the ordered pairs that work for this problem. Yes. Yes. Because it's greater than. Do we have questions on this? Let's do another example. Let's try number 2. Before we can really figure out if it's less than or is it greater than, because our sign may change. If it's going to be above or below, we don't know because our sign may change. The only thing we know for certain is that this won't magically become an equal to. It will stay less than or greater than, so it will be a dashed line. So we need to solve this before we do anything else. How would we solve this so that y is by itself?
Use subtract 4x and then
Subtract 4x on both sides. So we have negative 3y is greater than negative 4x plus 12. Divide by negative 3, and what happens when we divide by a negative? The sign switches. So now we have y is less than 4/3 x minus 4. So now I can say that the inequality says that y is less than So will we shade above or below? Below, because it's less than. Right? And now we can graph this. Start at our y-intercept of -4. We have a positive slope. What directions would we go to get a positive slope?
Right, down.
Up 4, right 3, or down 4, left 3, as many times as possible. Right? And then here is where you have to be careful. If you have to have a dashed or a dotted line, this can't connect all the way. You can put dashes in between your dots. But if you connect it all the way, you've made a solid line, which means you've changed the inequality. So you need to be very careful with that part. And then, since we're shading below this line, if it helps, draw arrows to show you which direction to shade, and shade in that direction.
How do you know it's going to
Because it's less than.
Oh.
Do we have any questions right now?
Wait, I didn't put it down.
If it's dashed or dotted, it depends on if it's less than or less than or equal to. Or whatever, or equal to. If it's equal to, it's a solid line. So think, if it has the lines, it is a solid line. Let's do one more of these together. Go to this example 3. Now notice that this is already graphed for you. They want you to find what is the equation or the inequality of this. So we need to know a couple things. Is this shaded above or below this line?
Above.
What does that tell us?
That's A.
That it's greater than. Now, looking at the line, because it's dashed, is that strictly greater than, or is it greater than or equal to? Just greater than. So right now we know it's y is greater than. Now we need to find our slope and our y-intercept. Y-intercept is 8. I know you guys are smaller.
Oh no, it's 8, my bad. It looked like 6.
And then find another point on your graph so you can count your slope. It should be -2.
-2?
So y is greater than -2x plus 8. So we're going to be doing this back and forth. Finding, actually graphing, but also finding the inequality for the graph. Do we have questions on this part?
No.
I want you to try these next 10 examples. So that's, oh yeah, and the you try it. So start with the you try it and then work on the next 10 examples. Don't move seats, just work on them at your seat.
Oh, wait, Miss Thorpe? If it's y equals greater than, is it what's it called? It's solid, right? If it's greater than or equal to?
If it's equal to, it's
My head, and that was it.
you don't know. You'd be surprised.
What about if it's
Mario staring at her.
Alright, let me get
Alright, let me get your eyes and ears. Gary, go back to your seat.
I just put a question mark next to it.
So I shouldn't hear anyone else talking but me. Alright, so I want you to check that you try it. Yours should have looked like this. Now, I did not make little dashes between mine because my pen is very thick, and it would just connect the dots, and I didn't want that. So I just left it as the dots. And if you have a slope like 1, you're going to want to do that. It'll take too much time to make tiny dashes. Okay, questions on this one? I just want to go over 3 and 6, and we'll go over the others later. So for 3 and 6, you have to remember 4 bucks. So for number 3, would this be horizontal or vertical? Horizontal. Would this be a dashed or a solid line? Dashed. So at -4, this would be a dashed line. And then would this be shaded above or below? Below, because it's left hand. Then for 6, would this be a horizontal or a vertical line?
Vertical.
Vertical. Would this be a dashed or a solid line? Solid. At -1. Now, your vertical ones are going to give you the most trouble, so I need you to think through this process. X is greater than or equal to -1. Which numbers would be solutions to this? 0, 1, 2. So anything positive that 0 doesn't count as one of those. So this entire side is going to be shaded. Okay, so just keep that in mind. We are going to keep going over the rest of those next class. If you did not finish this activity, it is homework. Earlier, I realized I never checked the homework I assigned from last class, so we'll do that next class.
What was that?
It was in
the packet.
the packet, yes.
Oh, this one?
Okay, yeah.